we can switch to the first step. So I'm using visual here to show some diagrams and steps and some information, but I'll compile it into a PDF file as well and share with you afterwards. So now we'll go, has a laptop and want to follow, we'll go to gitlab.com-n4468. And yeah, I'll show what to do next. For those of you who don't want to type, just can scan this QR code from your phone or tablet. And yeah, you can follow us in more read-only mode. So yeah, let's start with the projects. Why do I want you to fork it is because I might be sick or crazy or decide to delete it for some reason, or I'm blocked by sanctions for Belarusians at any time. And you will still have these projects and examples for CI if you want to and need to have some examples. So in any order, you go to the project, the first one, find this fork button, the little icon over here. And yeah, you can fork it into your private space. You just, after project URL, you select your own space, choose private, it can be public, it's up to you. You can click fork. Then you have this project in your own space. In private projects, you can always reach out to it. You can remove the fork link to initial project, so you'll not see any changes. You can do whatever you want. You can reuse it. You can rename, whatever. We will go back to initial page and we'll do the same with the second one. Fork, namespace, visibility level, private, fork. So I'm using some fake Gmail account for this. Now we'll need to clone this. I hope you made the registration. You have user and password for GitLab. If no, and you use, for example, Gmail authorization, and you don't have SSH keys to clone the project, you can click here, sign out, then sign in, and click forgot password, and you will get the password in your email address. Because we will need to clone this project, you need to authorize the clone, and you will need to use a user and password now. Or if you use GitLab on a normal daily basis, then you must probably have SSH keys. So for those of you who don't have SSH, you can click clone, copy HTTPS, go to your terminal. And today, I think quite a few people here will use Windows OS. Do any of you? Oh, not so much. Okay, so I will use PowerShell Windows terminal that I never use in my normal working life. Just to show it also works with the Windows and some, there are some changes. So if it works here, for sure it will work everywhere else in all the other systems. So I created a folder. I will type git clone and paste the URL of one of the projects. So if you use HTTPS and haven't cloned the project before, you will ask for a user and password, and I'll do the same for another project. So not to get back through the links, you can always go to your profile, click your username, click personal projects, and this is where you'll see these forked projects. I clone name, and I will clone another one. Why I'm using PowerShell is only one terminal available from the box in Windows, where you can type some normal Unix-like commands, and it's more or less Unix-like feeling. Personally, never use it. I use either Sequence or a terminal or mostly WSL, Windows subsystem, where you feel like you work in Ubuntu. So now we have cloned two projects. Let me make a quick overview. What is it? What technologies are used? We'll not go into the details regarding what is here. We'll not show code. It's not about the code today. There is a microservice called RESTec name. It's made with a Maven 3.8 and Java 17. I've used a framework called Quarkus. Is anybody familiar with Quarkus? Okay, cool. So credentials. If you click here, click sign out, you'll be signed out from gitlab.com. If you don't have a user and password, but you use some of auth methods, then you click forgot your password, you enter your email, and you will have a reset password for your email. This is how you can get the password next to your user. Yes, technology. So Quarkus is a very modern framework for JVM-based technologies like Java, Kotlin, Groovy. Works with Groovy. I've tested it. It allows you to develop microservices easily. I've developed a little REST API microservice here in minutes. You can generate it the same way as you do with Spring framework, but the big benefit of Quarkus is you can also easily develop with running your app in memory, and all your changes directly affects, and you can see it without rerunning the app, rebuilding, and so on. And when you need to add containerization, yeah, it's very easy. You just add a plugin I'll show afterwards, and all the Docker files will be in the project with the auto-generated README how to use these Docker files. You just copy the commands and you can really develop some little standalone service, Dockerized, containerized, like in the minutes. I will share a lot of materials afterwards. Yeah, what examples did I use? You can do your own if you want to develop some little standalone apps. For this service, I've used already GitLab CI/CD to create deployment process, and I'm automatically deploying it to a platform called Heroku. Why is because it's free, and yeah, the main is free, and it's very easy to set up in pipelines. So if I look at this microservice, it's available in public link. And what the purpose of microservice, every time it returns the JSON with 3 fields, first name, last name, and prefix, with some randomly generated data. I use GFaker for this. And yeah, I've brought a few tests just to check that fields are not null, and it's really random every time you get the new unique data. That's pretty much it. We can move forward to the next step, where we will run tests locally. So as I said, I've used Java 17 Maven, and if we try to configure all this locally for your laptops in different operating systems with different admin access, I will probably choose the first day where we have 8 hours. So we'll try to make it really fast and smoothly with the same way, just with using Docker. So what is Docker container? Who's really aware and confident that he or she knows what is Docker container and Docker image? Very few. Cool. So jealous. You can learn so cool stuff very shortly. Actually, when you use containerization with your local operating system, you create kind of little old school days VMware, but embedded in your system. So you have completely different operating system, very small one, running inside your OS. And yeah, you can have some pre-installed stuff and configure it completely from the box for you, like Maven plus Java. All you need to do is to run one command, and you have this container that you can connect to, execute commands, get the output, make some strong, difficult, hardcore things in different technologies. And how you can use it in your projects, for example, when you use some default tech stack and you need to use some project for another team, and they use completely different technologies, Python with some virtual environment stuff, and you really don't want to configure it for using it once or for a short time, you can just get this project and use Docker image with the correct versions of Python and whatever they need to run this app, and just use it shortly if you don't need to run it locally in OS. All you need to do is to, we already have cloned this project in your OS, whether it's Mac, Windows, or Unix system, and you need to share it with Docker container. This is where we start working with volumes. Volumes allow you to bind your files or folders with this Docker container. And the command that we will run, you can find it in a README file over here. And I will type it quickly for you to explain everything. So every Docker command to start the container starts with Docker run. So Docker run command always starts a new container for you. Some of them will be, will execute something and disappear right away. Some of them will be running forever until you don't stop it or until you restart your OS. Even after you restart your OS, some of containers, depending on the configuration, you can restart. So start again, and it will be healthy with all the files and pre-configurations. So this will allow us to run a new container. Then we'll add a few flags. -IT, this is a very common combination of flags when you run Docker container. It allows you to interact with it with the yesterday is standard input way, so you can use the console of this container. So we'll not have any kind of Ubuntu GUI now, but we will have a Debian terminal. So the image that I'll use is based on Debian. One of the most famous examples of Debian systems is Ubuntu. And we will all have the same version, the same kind of operating system running locally. And we will use this terminal. This is really cool. We all are on the same page. And in CI, we also use the same image and then make sure when we develop something locally, it will work perfectly, exactly the same like locally. Then I like the flag -rm that allows you to clean up this container after you use it automatically. Otherwise, if you don't use this flag, you will need to type docker ps, find this container, and kill it with docker rm or remove command. So I like T2Y mode. It's kind of allows, the combination of I and T is very common to operate with terminal that will appear right now from Debian system, and we can send the commands inside the container, and we can receive the response right away. So you will feel like you work inside this Debian terminal in Linux. You can run the container without it in detached mode, and you can connect to the container with the interactive mode afterwards. Then we will need to mount the projects. And to do this, we use the flag -v. If you use any Unix terminal, or in Windows you use WSL terminal, you can use pwd command that shows the path to your project. If you use Windows-based terminal, you need to wrap it with the square brackets. Thanks PowerShell that you at least support this. Then we use colon, and means we mount this path locally to the folder inside Docker container. You can call any way. I'm just creating app folder in root. That means that all the files from this project will be mounted inside app folder in the container. And then the tricky one, I'll copy this. This is an image version. So how do you find the correct image? And this is a very common question, usually common to me. You Google it. You Google Docker image Maven Java. It will redirect you probably to a page like this in Docker Hub. So you have Maven image. And you go to text, And sorry, you have a bunch of different image versions. You can click on it, see documentation. You can see the versions because locally I use Maven 3.8.4 and Java 17. I picked up this one. You can go through all the tabs and pick up the version that you need. That means for this Maven image that is based in Debian, as I said. Other than Debian, yes? How do we specify? Tag? Path? You call it any way you want. It will be working directory. It will be created from in this container, and all the files will be copied there. And this one. So if you execute this command in your console, it will show the this path to your folder. This is a command in all the Unix and Windows systems. The same command that will store this command. You can run it from your any terminal, like this one, and type $pwd. Then this is Sigwin. It will show where my root path. So version 3.8.4 Maven, Java 17. Slim means short version of this image. It's already like 200 megabytes or even more. I just used it for speeding up the process. We don't need to download the full version of image with any additional tools that we don't need. And then we run the command inside this container. I will just run dash to have this terminal up and running, or you can use shell if you're old school guy. And yeah, here we go. We are in Linux terminal. How can we check this? We can type Java dash version. You Google Docker image Maven. It will redirect you to a page like this. So this is Docker Hub where all the Docker images are published. You can also build some image locally and publish here. This is official one, supported by Maven. You can go to Text tab and you scroll and go through pages, find the correct version that you need to use. The newest version 3.8.5, OpenJDK 18, Java 18. I didn't know that it exists already. 5 days ago. Crazy. The world is so fast. Wow. So you just find correct version, go through pages, there are a lot of them, or you Google directly Maven 3.8.4 Java 17 Docker image, it will redirect you to the correct one. Yeah, if you go to any tag, there will be some specification, what versions are here and what tools are pre-installed for you. So we are in Linux terminal, all of us are in the same terminal. So if we type -v, that is Maven version, it says Maven 3.8.4, Java 17 is configured, all the path environment variables are here, Maven home is here, Java home is here. We don't need to do all this stuff, restart our computer 5 times. Yeah, here we go. This is, yeah, I think this is really cool. We can run the system. It will be the same system as in CI. It's for sure not crashed with any local configurations or 10 versions of Java that, yeah, I have locally like 5 or 6 versions of Java. If I want to work with different projects locally with Java 8, Legacy 1, I need to change path environment variable. Source it. Yeah, not forget to get back when I'm working with my main project. So it's, yeah, horrible. With Docker containers, it's really easy. And if we go to app folder or dash app in the root that we created from this command and type ls command, we see the files from our project. That means this project is here actually. And yeah, ls command is powerful one. You can type ls-l with a nice list view and size. -a flag allows you to also show hidden files started with dot, like git ignore. I don't like this size in bytes, so I type flag h that shows correct, nice output in human readable format. So less command is what I'm using more than, yeah, whatever else. All right, so we are in the project, we have all the versions configured, we can run tests against this host. I hope it will not die now. So all we need to do is type one command, median test, and that's it actually. It will install everything needed and run tests. It will get all the dependencies from Maven Central repository and install it in your Docker container as we mount it into Windows, in Windows or whatever operating system you use. We will have the output that is target folder for Java. And yeah, you have the output. If you exit from this Docker container, run another one, so it will already use all the pre-installed and pre-configured files with all the packages here. Yeah, that's yeah, pretty cool, I think. If you don't have the version and you, for example, want to open this project and open IntelliJ IDEA or Eclipse or whatever IDE you use, it will get all these pre-compiled files from Docker container, and you can use it even in IDE without pre-installing all the packages. So depending on the internet connections, it might take a few minutes. At home, it took like 20 seconds. Yeah, we see that something is running. Tests are finished. I have two tests. One is checking that some field is not null. Another goes to endpoint twice and see that name is unique. So name is unique as well. And yeah, we have ran the Maven Java project without pre-installing something. Yeah, I think pretty cool. We can move forward. Please leave this terminal. We will use it later.
I don't know if others are at the same speed as you, but it downloads this image still. But if everybody starts to go down to Wi-Fi,
Oh, internet is very limited here, right?
yeah.
I use second one. Nordic Days too, because the first one was so slow.
So there are two VPNs. And
Just the second one.
it should be a private for this room. All right, let me go through Heroku while this is downloading. Yeah, the first time, if you want to pre-download image, you can use docker pull command that you can see from here. So when you find the correct tag, you just copy it and you can make docker pull, then docker run will execute it right away. And I have lots of Docker images pre-downloaded, all the possible versions. So while it's downloading for all of you, I'll get back to Heroku platform. Let's see if it's still up and running. So with adding two keys by documentation into GitLab, you can deploy app for free in cloud and share with anybody. Yeah, you can access it by public link. And yeah, there are some cool features from Box. I'm still using free account, but you can view logs of the apps. You can have different apps. I think for free you might have up to 5 apps. At least it was so before. You can run console of this app, and yeah, you can send some commands right away, test how it works. You can add some pipeline right here in Heroku that we are not interested today. But for example, view logs, you have a nice readable terminal, and there are my logs I yeah, prepared when developed this legal microservice with the REST API. There is an endpoint dash name that I've called here, method get main host, and I'm printing the where am I printing? Yeah, I'm printing the object that I generated, so we can see that in tests and here, yeah, objects are the same. Once all of you execute all the stuff, I think I'll have huge logs. And what is nice in Heroku platform, you can yeah, use it kind of forever because it's not consuming. Once we stop using it for 1 hour, I guess, it will go to sleep mode. And once I call the endpoint again tomorrow, for example, it will take for the first time like 30 seconds. It will be warmed up and started again from scratch, so it will be restarted automatically.
This is free, right?
Absolutely. There are, of course, paid plans, but I've never tried any paid plans myself other than Google Cloud stuff, and it's incredibly hard to remove your card from there. I've called a number in USA to ask support to please remove my card, stop charging me after trial period. It's almost impossible. I've Googled for 5 days how to get rid of my personal data from Google Cloud. No.
I think we need to have an account.
Yeah. If you want to, I think you don't have the access to this project in Heroku right now. You can create your own. You can sign up, I think, with Google account as well, or even with GitHub or so. And yeah, you can create app. I will share also links how to easily integrate with, for example, GitLab CI system, and it also takes like minutes to deploy your app in some public space for free. Is
required for this?
No, for you it's not, just showing. We'll run all the stuff locally. Can we continue? Is pulling Docker image done? Did you execute Mivian test command? No. Wow, that's quite unexpected. How can we speed it up? Is it so big? Docker image.
I guess you had all the layers locally. There's a lot of layers.
No, it's 400 megabytes. Yeah, at home it took like 10 seconds. I was expecting at least no more than 1 minute here. Let me move forward with the theory part and we will type command afterwards. So, yeah, I see some more requests. So somebody is executing Mivian test command. I can see it locally from the terminal. So moving to the next step. After we run, yeah, this is how we usually prepare our tests. We have some environment, I called it -acc to have a feeling it's acceptance environment, sandbox test, whatever. And we prepare tests based on some working system, right? Developers say it's running in test environment, you can connect to it and write some API tests, but then before the code is deployed to this environment, we cannot test new code, we cannot test new changes. This is what we want to change today. So the next step, we'll try to use containerization of our microservice and have it up and running in localhost with the same kind of technology. And there is a tricky part. So in the previous step, we created a Docker container where we needed Maven and Java only, but especially created the microservice without preparing the image for this service from pipeline that I can pull. Ideally, if you have a nice development team, developers are using some orchestration like Kubernetes or Docker Compose, for example. They have published and released these Docker images somewhere. Not in Docker Hub, most probably, but in some internal system like GitLab or Artifactory or Nexus. And you can pull this image once it's built in CI and test it. So in this case, I didn't prepare the image from microservice pipeline to make it more hard. And we'll build this image right now. So we'll get the code of microservice that we already pulled locally, and we will need to build the image. So now we need a Docker container that has Maven, Java, and Docker. It's called Docker in Docker technology. So when you execute Docker commands from Docker container. And the problem is container is not really VMware or so. It's not a real system. So you need to bind not only the project, but you need to bind Docker daemon via Unix SOC. So there is extended schema a bit. So other than mounting a project, you need to say this container that it can use our Docker daemon from the host. So when you execute Docker commands inside the Docker container, like Docker in Docker, it will be translated into your host and will be actually executed in your in your laptop, in your local OS. So with this, we need to add one more volume. It will use the technology called Unix socket sharing. So Docker is just a tool, provides us with a few commands that we can install anytime, but it needs to use Docker daemon. You often might have errors working with Docker, like check that Docker daemon is running in host 2, 3, 7, 5, whatever it is. And this is where the Docker as a tool is running, but daemon has died. And daemon is what is the power of Docker that really creates all the containers, move them to your networks and so on. So we'll use a bit extended command now that you can find in the README file of, where is it? In a GitLab. So you can either change paths here or again go here, personal projects, and find the microservice. This one without dash tests. There is some README. So yeah, please, sorry, didn't think about internet. If you're slowed down, we'll have some time afterwards. All the documentation is here, commands are here. You can just copy it. So we'll move to this block with the built-in applications inside another Docker container. This is what we'll do now. So in a new PowerShell terminal, leave the previous one, please. We don't need admin mode, by the way. I don't have one. Or at least my admins think that I don't have admin role. Seriously. I will scroll it a bit. Yeah, this is a limit. I'll switch to my folder and to the project. So I'm in this project and I use almost the same command as previously, but with the one little difference that I'm also mounting this var run docker sock from our operating system. Doesn't matter which operating system it is, it's always under this path inside the Docker container. The rest is of this command is exactly the same. So it also spinning up the Debian container with the same Maven and Java pre-installed, and also it mounts the Docker daemon, but this container doesn't have Docker yet. I didn't find any publicly available container with Maven, Java, and Docker. But once you get container without something, you can either build your own image, I can show it afterwards how to do it easily, or you can install it from this terminal because you're always admin with the sudo su rights in Docker containers. So there is an installation instruction. We need to run apt-get. apt-get stays for Debian systems like Ubuntu. Update gets the fresh list of all the latest packages. -QQ means silent mode. I don't want 1 million rows of output to show now. And then you run install -y because you will be prompted like, do you really want to install this package of 100 megabytes? You'll say yes. And -QQ again is quiet mode. And then we finally say, what do we want to install? Docker.io. It will install Docker commands. So inside this container, we will now have Maven 3.8.4, Java 17, and Docker, whatever version is the latest, always the latest one. Or you can also specify with colon the version that you need to, but for Docker, it's really doesn't matter what the version you use. At home, it took another 20 or 30 seconds, so let's wait for it to install for everybody. Yeah, I think the internet here is really limited. It must be in my metered mobile network. I think it will be much faster. So yeah, meantime, just one more time. When we want app to be running inside Docker container, we first need to build image of this app. And to build image of this app with some tools like Java and Maven or Python or PHP, whatever you use, you find correct image. If there is missing command tool like Docker, you install it with a package for Debian. It's apt-get install something. CentOS, Red Hat, it's uminstall, Alpine, apt command, and so on. So depending on what image do you use, what Unix system is it? Oh, it's actually also possible to use Windows containers. Have never tried it, but people say it works. So if you have old school ASP.NET applications running only in Windows and you have Ubuntu, for example, you can also run Docker container with a Windows and yeah, have this PowerShell, this powerful, nice terminal coming from Windows for you. You can use it from scratch. So nice terminal. So like it. It's blue, dark blue, amazing. He didn't hate it.
I have a question.
Sure.
In your example, you have Docker inside Docker, right? How many layers can you have? For example, I have like Jenkins slaves that are actually Docker containers.
Yes. We'll use GitLab runners now that are also Docker containers, and you can have as many layers as you want because all of them will not go through like all the chain, but will be directly mounted to the original operating systems. Depending on CI tool, you might have additional service running that will help binding all this system nicely depending on the configurations. I'll show how it looks for GitLab, pretty easy. But yeah, well, it's always nice to answer. Just Google how to use Docker in Jenkins, in TeamCity, in Bamboo. I've tried almost everywhere. It works. I've tested 5+ layers Docker and blah, 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 blah. And yeah, it works perfectly fine. At least Unix operating system doesn't care about it. Yeah, so it's finally installed. I can type Docker commands. I can type Docker PS inside my Docker container, and it knows about 2 containers running in Windows. One is with a test terminal, and other is this one. So it knows about even this terminal that is inside, because physically this Docker daemon is executing my Windows operating system. We are ready to build the image, and what is really cool in Quarkus is if we need to add some feature like create REST API endpoint, we find Quarkus documentation for REST API endpoint, and it says add this Maven dependency or Gradle dependency. You add, everything is generated. If you want to use Docker images, it will generate all the Docker files in all the possible combinations. It will create Maven build files for you. It's just a matter of seconds to get it auto-generated. And what is really nice, it also prepare auto-generate README documentation once you add a plugin. So it says Docker, where is it? Yeah, it predefines some documentation with how you can build it in Docker mode. So here is the next command. Yeah, first we switch to app folder again. We can write ls -lach again to show all the files are here. It's now a microservice terminal with all the files mounted from Windows. And now we also have Docker inside this container, and we'll copy this command. And while it's executing, by the way, in PowerShell, Shift Insert doesn't work, Control V doesn't work, Control Shift V doesn't work, so I'm copying and pasting with mouse too. PowerShell, thanks, you at least support this. So this is Maven command that goes to our pom.xml configuration file of this microservice, find the correct plugin. Let me see how it's called actually. Quarkus container image Docker. Yeah, this is what all I added, and it also pre-configured Docker files for me. I didn't write any Docker file row, and it adds the command as its plugin. It adds the ability to use the command with the passing few arguments like Quarkus container image build equals to true, allows us to build Docker image from the packages that it will use from installation. And you can call it in some custom way. So I want it to be called my repo name and colon version. In CI it will be different one. So I've also prepared some instructions how to extract versions from POM.xml file, because of course in the top of POM.xml you always have a version of this app. So you can use it for this version from here, and there is another plugin. I've shared some documentation how to extract this version into your terminal. But yeah, for simplicity, just let's hard code it for now. So this command will get all the packages from Maven Central repository. It will build a Docker image for this microservice, and we'll call it this repo is called with some custom tag. After this, we will be able to run a container with this microservice locally. Let's see if it's actually finished. No, not yet. It's horrible connections here. But yeah, we're almost finished. So yeah, well, it's installing. Is everybody in the same page, more or less? No. No. Is it because of internet or? Oh my god. If you hit enter maybe a few times, maybe it's freezing because of... My god, it's horrible. Yeah, we'll have a little break afterwards. So yeah, maybe if there are some technical issues, everybody will be able to finish. And we will finish typing all these tricky commands soon. And it will be more like a demo in the second part. So actually the image is built. How to check that the image is built? Is it here? Filter. So you can use this command, docker image -- filters equals to. It's very advanced. It's a nice one that will show all the columns and nice output. But almost nobody uses it in real life. You type docker image ls. Let me clear this. Then you type vertical line, because we'll after this output we don't want to type all the images. We type grep. That is kind of filter in Unix. I think you're familiar with this. And we can I don't know, copy this name. So yeah, I cannot paste with shift insert. It's horrible. So it will get all the images and only grab the images that matches to this name. And it says, this is an image. Registry 1 docker.io is the registry namespace where it will be published if I want to publish. This is default Docker Hub registry. So I can actually type docker push this command, and this image will be published into my personal account if I make docker login, and it will be available for everybody via this hubdocker.com. I don't need it at this moment, but this is why there is this prefix, and I shall not be scared of it. So the image name is this one, tag is this one, built about a minute ago, and it's 400 megabytes. This is a downside of using JVM-based technologies like Java or Kotlin. It's even worse. It's always really heavy. There is one microservice with one endpoint, but because of some pre-configurations, dependencies, transitive dependencies, lots of pre-configured stuff in the Docker and other stuff, it's really huge. I can't imagine working with this kind of images like 5 years ago. No computer will support it. In CI, our admins will kill us if we try to run containers based on kind of these images. But now it's not a problem. In our projects, we have images weighted for a few gigabytes. We still use Node.js. It's even worse. Okay, so we have this image, and based on this image, we now can run the container. You can run the Docker container from any terminal, or because I'm bound in Docker inside Docker, I can run it right from here. So you copy the last command with docker run. Let's see what it actually does. No, didn't copy. So again, starts with Docker run. -d means I don't need to run console right now. I just let this container running. It will be running in detached mode. I will not see output. I will not really wait until it's up and running. It's kind of asynchronously running the containers, or even not asynchronously running, but publishing the command inside Docker daemon says, please run in background this Docker container. I don't want to wait until it's really up and running. -I, it's again interactive mode. We don't need T parameter bits because we will not use string standard input output from console. -rm means when I finish with everything, if some process is broken, if my app is broken, if I'm not good tested it before, then it will be down and container will be deleted itself. I will not keep my container always living before I kill it manually. And U parameter -p means publishing a port. So I configured the app to be running in port 8080. I hope you guys don't have any processes running in 8080 in your OS, otherwise it will fail. Then you can change it to whatever in left part, like 8081 or 2 or whatever. Do I have insert pressed? Oh my God, I like PowerShell. Let me recopy it. So you can change the left part, then you will allocate local port, with different address, but you will still point to 8080 inside Docker container. In my case, I don't have any process. I hope I don't have any processes running this port locally. So it will mount the socket now. That is where all the protocols in your OS running, either it's HTTP, HTTPS, gRPC, whatever. Oh, it's not allowed to leave the room. Nice. Then you provide an optional flag --name. If you don't provide this flag, this container will be called in some random name with some actor or some, maybe naming of some famous lake or whatever. It's, I don't know, funny technology of Docker. It's always naming somehow really nicely. I want this name as this to filter easily by this name afterwards. And then you actually use the Docker image we just prepared in the previous step. So if I execute this command, it will type the Docker container ID, the full hash of this ID. If we want to see the show version of this, we can type Docker PS, and we will see that this image with this name is in this container ID. What does it mean for us? Not a lot. We can see on the logs. We can check that it's up and running via Docker logs. So for Docker logs command, you can either use this ID so you can copy, or if you see that this ID is unique, you can use a few first symbols of this ID. You can type 58C2, for example, more than enough. For sure, I don't have any container starting with this ID. You don't actually need to copy the whole ID every time, especially if you have something important in your clipboard and you don't want to clean this. So you can type a few first unique symbols, and it will show out the logs from this container for your terminal. And I see this app is already running, and how to easily prove it. I am opening localhost 8080-name, and I'm expecting this response here. Exactly the same one like in this kind of fake ACC environment. So this container is running locally now. And what I want to do, I want to run tests against this host. So to being able to make this, as I said, shift left testing. So to get this code locally and test it before it's not just deployed somewhere, but even merged into developer master branch. So when something is developed, they can pull, build, run, and test locally. So finding potential problems and developing new tests, changing existing tests in very early stage. So we even allow to, following this way, we can avoid problems even in test environments. That is, I think, really cool because test environments are usually really important. Many teams can use it. POs can use it for showing POCs in some kind of pre-production is done. So sometimes for us, for example, it's really important to keep test environments or sandbox environments up and running. So I'm testing everything in isolation, locally with Docker containers, not caring about some broken data in ACC environment is not up and running. It's memory leak there. So yeah, I control everything. I like this power. So to run tests in this environment, I already prepared the configuration. If we go to the first terminal that we didn't close before, we can run tests with one Maven parameter. To explain what it does, I will quickly go to GitLab repo and typo, and I will open src main, trying to follow these standards, with all these packages. Never liked it. And there is a config YAML configuration that I prepared for different environments to reach in the host in ACC and localhost for development from right from the Windows machine, and Docker environment and Compose that we'll use afterwards. So there is a host that is tricky one, 172.17.01. Is anybody aware what is it? No, so yeah, quickly explaining, it's called Docker 0 IP host. That means this is a host that you use for connecting different containers, because I can reach to localhost 8080 from my Docker machine. But if I run, if I try to curl this command from first Docker container, it doesn't have any processes inside this Docker container in localhost. You can run containers with a host network that is very not recommended because of security reasons. Then it will be able to share also localhost with your local system. But in default, we didn't run anything related to networks, as you saw. That means by default, it uses bridge network. Let me show it really quickly. Yeah, here I have Docker. So if you run the trick command, Docker ps, we just see a container ID, image port, yeah, and some other stuff. But if you run it with a -- format, and don't try this at home, table, and we prepare it like this, it's very weird. I hate it. But sometimes we need to know tricky commands. And I will copy. This is how actually Docker is structured. And here I will have outputs for not only columns that we had before, like image, words. It's an official Docker documentation, but I think the syntax is horrible. Names and networks. You can also print out the network where these Docker containers are running, and you can only talk within Docker containers under the same network. If they're running in different networks, not host network, it's impossible to talk between Docker containers. This is where a lot of orchestration tools come, and this is what we'll see in the next part that creates temporary custom network, but by default, it's always bridge network that created with Docker installation your operating system. And if you want to see the IP of this network to talk between different containers, we can run Docker inspect and the network name. There are actually also containers by ID with some MIT information, but this is what we are looking for, gateway. Based on your local configurations, you might have a bit different, but most probably if you don't change some default Docker configurations, you don't have different gateway. So this is what is called Docker 0 IP. Yeah, quite weird. But if you especially configure Docker in Docker, you will need to use it's a lot. And we can catch this ID in a nice way, just parsing this output. Also, I'll share all these commands for you afterwards. So it's Docker inspect. first I will run docker ps to get the copy container name, and I type docker inspect. Then this either a docker container ID or docker container name, and then I say -f, and tricky one, don't write at home as well, json.network settings.networks. Yeah, it will get this inside block by parsing this JSON. And where is it? Docker inspect format table networks. And there are some other, I will show it in GitLab CI part, how you can extract some inside. But you can see it's parsed. So from Docker inspect, it's really tricky. So I just decided for this app to copy this IP. So now, by providing one more parameter in the mvn test command, we will run tests against our local host. And I go to this PowerShell terminal with the tests container, and I will run mvn test -d env. This is how I created the parameter. -d, this is how you send parameters inside Maven. env sounds like environment equals to docker. Then it will parse this YAML file and get the Docker host and the port 80 and 0. And you see now tests are running against this Docker 0 IP host for breach network. I hope it will work. I'm not sure why it takes so long. Yep, it's finished. Is everybody following? Cool. I think it's pretty cool. We have two containers running. One is with microservice, another with tests, and we connected them via some crazy technology called Docker networks, and we now a little bit understand how to make this kind of integration. And all we actually need to do is to move all this stuff into CI in the next part. So we'll have 5 to 10 minutes break now. And if somebody needs help, I will pause this recording meantime. Continue this recording. It's now time to have combined all the stuff that we did before and move it to some CI system. What I think can help a lot, especially in kind of Scrum teams, I have heard these concerns like, did your test pass? When did you run it? Please run it somewhere where you can see reports. I've deployed it 5 days ago. So I think the best in this team, what you can do is to integrate your test, whatever you have, into development pipelines. I'll show it shortly how to do this. So first you need to prepare CI to run your tests. Ideally, if you can test something in isolation, running in Docker container is really cool. That means you can actually test a developer's code in a branch. That is super nice. They can run unit tests, build a solution, ideally build a Docker image for you and release somewhere. Or we can build this image our own, like I showed. And we can test this image with new version, not was deployed in some sandbox or test or dev environment, but before it's even maybe reviewed, you can give a feedback for integration test to developer right away in a few minutes. And this is, I think, what is really cool, and I'm always trying to achieve that. So let's try to move to CI. I will ask you, if you're super confident about writing YAML files, you can follow me. It will be a quick one. Otherwise, you can go to test project that you cloned. And I've prepared a branch. So if you go to repository branches, in left panel, the expanded menu, just hover cursor, repository, go to branches. There is a branch called CI. And you will see some files that I will create and explain what's happening inside. You can just open these files and follow me. I will go back to my main master branch and create these files right from the browser, because I also didn't have the requirement to pre-install some IDE, and I'll show the ability of GitLab to create files right here. So before we do this, let me explain what are we going to do. So first, many of you who was working with some container orchestration tools might think that you're crazy, you're running two containers, checking this network IP, trying to hardcode it somewhere, and make sure that are really running the same network. There are tools like Kubernetes, hard one, don't talk about it today, Docker Swarm and Docker Compose. The most old school one, one of the most famous. So let's choose Docker Compose that will help us to run this microservice and the container with tests under the same kind of configuration, and make sure it's all connected into the same network, and we can run it with one command, not run one container, another, and switch between terminals. What are we trying to achieve here? So we will work with the GitLab CI that is actually just interface, a nice GUI interface with many features, can show even 1% of what I know in a whole day to you. But what it does, it connects your pipeline to some remote machine called GitLab Runner. It can be service, shell service installed machine. It can be Docker container in the most of cases, and it can be some container inside Kubernetes system. If you use Kubernetes, if you have apps deployed here, it sometimes does make sense to run a pod with your tests inside this Kubernetes system under GitLab Runner. Hard stuff, we'll not talk about it. But the problem is every job in GitLab CI is independent from each other. It's quite tricky to even pass files between them, and I'll show it. But connecting containers started from different jobs is hard part, because we need to make sure they're running the same GitLab Runner. Sometimes it's not possible at all. In the most of cases in your organizations, you have GitLab or whatever system for CI you use installed locally. Then you can configure GitLab runners yourself, that I do a lot. Enjoy this Linux configurations. It's amazing stuff. The best what I do in my life. But it's artifacts, but not connecting containers, because they can be even started in different machines. Machines can be in different countries, in different metrics. So sometimes it's really impossible to start containers in different jobs and connect them. That's why we need to either start containers, prepare everything for them in one job to make sure it's running in one machine. But again, the problem with networks, if you configure GitLab runners yourself, you can go to config toml configurations of GitLab runner and set specific network. Otherwise, it can use some network not available from the host, many security layers, and you will never be able to connect containers. I'm using gitlab.com now. Don't use it at work until you have an unlimited plan from gitlab.com. But we have our own hosted GitLab. Actually, we have 8 different GitLabs in the company. This is only what I know. And our own runners. But for this demo, I've used gitlab.com free runners. I have no idea where they're installed, what configurations they use. I've tried to do this as POC for myself. I was not able to connect these containers, and that's why we will use orchestration tool called Docker Compose. So with Docker Compose, we make sure that we have containers running under the same network. It's temporary network usually created by Docker Compose. You can control only some prefixes of this network. So you spin up this network, create containers inside, talk between them. There will be in the same cluster. And once containers are down, this network will be removed. So you can control this. So now we will prepare CI. You can follow the screen and check whether I'm doing everything more or less correctly with your branch version. So I'll go to GitLab, scroll a bit more, collapse this one, And there is actually a nice web IDE. If you need to make a little update and you don't want to commit and push and get back to terminal and see, it's a very nice way how you can change some file, especially if it's README or some configuration, not really Java or some other code. So you can click this create, and it already proposes to create some files that are missing. I will start with Docker file. With the Docker file, I'll prepare now an image for my test solution. That's quite easy one. So Docker files, almost always before last versions, starts with the from. From means the base image. But for base image, of course, I will use the same one as we use for CI. So let me copy this Maven, blah, blah, blah. So means I will now use this image and will extend it with some stuff. So we already know how to build this image and so on. We often might want to use work directory that will create a dir same as I was mounted from docker run -v, and work dir will create this folder, and we will be by default in this folder executing all the commands. We don't need to take care about switches, and yeah, we can call it whatever, user ape. Then we will copy. We don't need to copy everything. We need actually only POM.xml and src. So let's copy src under user app src. It will copy all the files from my local src folder into this Docker image. Then I will copy POM.xml under user app, and we'll run command with run. Run means just execute this command inside this image while you will build this image. Run median clean install. I don't want to run any tests during installation. I will skip it with flag -d skip tests. And that's it for this file. I will create one more file called Docker compose. It doesn't suggest me, so I will type it myself, docker compose.yml. For YAML files, you can use two kind of extensions, YAML and YML, and Docker compose only works with under YML files. Quite weird. So for Docker compose, you always start with version, and I've just noticed there is 3.9. I've just switched to version 3 a few months ago. It's already 3.9. World is so quick. And services. This is a blog that identify all the Docker containers we want to run under this Docker compose configuration. For services, we can call it any way you want. Doesn't matter. I will call start service, and I will need to use image. So for service, I want to prepare this image in CI, run all this build stuff in separate job, then push this image somewhere in GitLab and use this image in the next stage where I will run tests. So I will prepare this image, and most probably I can provide this image from environment variables, I mean name. Tag will be different. I don't want to hard code it here, I want to build it nicely. So I will grab it from environment variable, service, image. Let's call it in this way. It's up to your imagination. Another block is ports. We know this part. It's a list. You can provide multiple publishing ports. You can run multiple apps in your Docker container. So it's a list. We have just one mapping, 8080 to 8080, and that's it. This is an replacement of what we previously done with Docker run command for a service. Another part, another service or another Docker container that I want to run here is tests. You can again call it any way you want. And I don't have an image for this test, but I have a Docker file. So you can have a blog called build, and you provide a path to this folder where Docker file is. Path is this project, because I'll have Docker compose and Docker file in the same level. Or you can provide a custom Docker file path. So it means this job will view this image and then can run a command. For command, I want to run tests. It's quite obvious. So I need to send command inside Docker container. For this, I can use bash or shell. I will use shell in this case. sh -c means argument that I want to send inside shell. So we'll run shell terminal with a command medium test -d env equals not to Docker but to compose based on some configurations of free runners in GitLab. I didn't configure any. I will configure it with the same Docker subnet system. It will be 172.17.0, but because of I already know the problems in free shared Docker GitLab runners, it's a bit different configuration, already prepared in a config. And I want to run tests only after service is starting. If you don't have any dependency, they will be executed in parallel. I don't want this. Test will fail because service will not be reachable. So there is a block depends on, and there is again a list. You can depend on many jobs. It doesn't matter the order of services that you run. It's for YAML file, it never counts the order. So you can type build in the end. You can switch start service and test. I just type it to keep the logic. But if you really want to depend on the previous job, you have a block called depends on. And I want to depend on start service. Obviously, I want this container to be started. Then I want test to be running. If you have some service that is starting for a minute or so, you will need to write some shell script that will wait until it's really reachable, write some shell command that will curl every 5 seconds. So yeah, depends on just an order of execution, but it will not really wait until service in port 8080 is running, type in Quarkus in console. But I know the service is starting right away. It's very lightweight microservice. And that's it for now. I will extend it a bit more later. And one more file, the last one, that is GitLab-CI YAML file. And this is a configuration for pipeline. Once you have this file correctly configured, you will have pipeline up and running after the first commit. So let's start it. It's the biggest file for today. So in the file, what we start with is, I personally start with stages. Stages mean what kind of set of steps or steps do you have for your pipeline. I personally want to have 2 stages. In the first, I will build service. In the second stage, I will run tests. Then it's tricky part regarding Docker in Docker. I will share link, not spend too much time on it right now, but services. This is what I've a bit talked before. You need to say to GitLab runner that is actually a service running in some remote machine, different machine from what GitLab.com is running, to have some additional shell executor to help connecting our Docker daemon inside this Docker GitLab runners, because they have GitLab runners all in Docker by default only. And you need to help to understand this GitLab runner to connect Docker and Docker. So to map all this stuff, it's an official documentation. And where you can also see this, by the way, in image README file. So yeah, I'll show it in a minute. So services is also a list. I will have only one called Docker, and version is, yeah, it's the last one. DIND usually stays for Docker in Docker. So DIND means we are working with Docker in Docker. It will help us to connect GitLab runners with Docker socket, with Docker in Docker commands. Hardcore stuff. How did they implement it in Ruby? Can you imagine? GitLab is fully managed in Ruby. Horrible language. Variables. Other than connecting a service, now we need to volume this var docker sock file inside GitLab runners. It's a very tricky part, again from documentation. You shall not remember it, just know that it's here. So one is Docker host, and it should point to TCP -- docker 2375. There is a nice link I will share afterwards regarding how all this magic works. So it's actually the same one like we ran a container with -v and connecting Docker daemon inside the container, but in a very tricky way. And Docker TLS, because there is no TLS file for this Docker and Docker that GitLab requires, is empty. Otherwise, it will try to use some certificate that we don't have, of course. And one environment variable that I will set right now, show later how to use it, is branch. I don't want to always test master branch of my microservice, but I will make some changes in different branch and show that it actually can test the branch. So I want one pipeline in microservice triggering another pipeline in test and say, please test under this particular branch. And I will send this branch name from pipeline. And I will call it dev branch, not to confuse with current repo branch. And by default, it will be master, but I can send different parameter. So now the jobs, actually the jobs that we will see in pipeline. We can call it any way we want. I will call prepare service image. The job always has a stage. I will copy, not to typo, with space. Then it has a few blocks of executing the scripts. The main block is a script itself, where you can run multiple commands one by one. It will be executed exactly in this order. This is actually executing this command remotely in this machine inside Docker instead of running it locally. But where we will run these commands, we need to identify Docker image. And that's why we have image block as well. And for image, I will again copy this one, because this is where I need to build my microservice image on the fly. So for script, this is a list. A second. So yeah, for scripts, I want to build the service. I can type echo to keep it easily easily find these pieces in CI. Building the microservice. But before I can build a microservice, I need to reconfigure this Docker container a little bit. And you can do it right before this script, or there is also a block called before script. It's a bit more easy to manage all this huge amount of commands that you have remotely with the blocks before script, and after script. I'll show it afterwards. So we need to do some tricky stuff here. First, remember we have Maven and Java. We need to install Docker apt get update -qq quiet and apt get install -y -qq docker io. And I need to pull development repo right now here, because this is test repository. I need to work with development repository. Another approach is to use Git submodules. Don't want to show it today. So I'll also pre-install Git. I don't want to see this million output records, so I will redirect the output of this script, because I don't care, to def null. And a bit more crazy stuff from this Ubuntu, just not to show anything, just silently install and forget about it. Then I will clone the repo, because this step will install Git. I will have image now with Maven, Java, Git, and Docker. Some additional tools like ls, of course. So I can git clone for finding correct path. I will go to my development project. We'll go here and copy HTTPS1 and say git clone this one. that will not work because configurations are not configured yet. Stay with me. Yes. Locally, you have in your Unix system configured username, password, but this is a raw Docker container with just pre-installed Docker mounted via some mechanism to GitLab runner. And now we need to explain how to get credentials for HTTPS connection. And for this, GitLab provides a built-in username and password called GitLab token. So there are a bunch of environment variables existing inside all the GitLab containers and jobs. For you, you can always find for GitLab CI predefined variables. You can open this link and see all the variables you can use. It's always exists like branch name, repo name, project ID, different timestamps, whatever. So I'll use it right here. There is a kind of user called GitLab-CI-token, and it can use the password that is built in. It's not actually password, but token called CI job token. I didn't pre-configure it. I promise it's existing in GitLab always from scratch in any GitLab. Even if you install GitLab in your laptop and spin up and write a job, it's all existing. This GitLab CI token is a special kind of user, can use CI tokens and doesn't eat the license, because GitLab license, the enterprise edition, it's when you create users, it of course uses the seed, the license count place. GitLab CI token is created by GitLab and it's free, doesn't count the license. So in this way, you can clone with these credentials on the fly. I don't need to write git configure, blah, blah, blah. So just with one row. So after we cloned this repo inside, we need to switch inside this repo and thus inside this folder and run build commands. So we will make cd here, and we want to work on specific branch. But if you clone the repo in specific branch, there might be commits in different branches afterwards. So to make sure we have the latest commit from particular branch in CI, we need to make a little bit of magic here. So we will run first git checkout this $dev branch, and one more command to git pull --ff only, means fast forwarding only. We don't want to resolve some conflicts, of course. Origin, and from where? From that branch. Be tricky, I know, but this is how you can pull the latest changes in particular branch from completely different repo from CI. I can use it actually. And the last but not least, I need to build this image and then push somewhere. I don't want to push this image in Docker Hub for everybody. It's quite weird, but I want to push this image right into GitLab, because GitLab is so amazing platform with all the possible tools you can imagine for DevOps. And GitLab registry is here by default, always switched on by default. You can shut it down, but yeah, it's really cool that we don't need to pre-configure some Nexus or Artifactory where we can push images, but use GitLab registry with all the credentials you can grab from the package page shot with predefined variables. So I will make Docker login inside this registry to afterwards push there. So in before script, I move all the pre-configurations for main scripts, make less noise. So it's tricky command for Docker login. So we'll echo $CI registry password, then vertical line, Docker login -u stays for user CI registry user, and registry itself that stays in the variable CI underscore registry, and -- password std in. Grab from official GitLab documentation. We'll share this link as well. So this is how you can perform Docker login to push image that we will build later inside GitLab registry right here. Hope it will work. So building the microservice. I will stop typing and we'll grab it from my README file. What do I need to do? So previously we hard-coded the version. I want to extract it from a POM XML file. I will just copy all the scripts. So with this special plugin, I will first remove -snapshot because I don't want to release image with -snapshot. Then I will grab image with this command. Then I will, I think I need to run clean package command. Yeah, I can either use this one or yeah, I can copy it like this, or I can run row mvn command. This mvnw is what is generated by Quarkus, allows you to run some via scripts via some checks and so on. So it will build it will build Quarkus app Docker image, and we need to change it a little bit because we don't want to be with prefix that points into Docker Hub. So we'll use another variable called CI registry image. It will be your namespace, your personal user, dash if you created a group, then group, and the name of the project. So with the whole path to GitLab registry host, I don't even remember what is it. It's always in this variable. You shall not take care of this. So with this, you will prepare image, not with pointing to Docker Hub, but pointing to GitLab registry. So all we need to do is Docker push, but before Docker push, I want to show in logs that this image is here. I will type Docker images and we'll grab this one just to see that the newest version is built like 10 seconds ago, and we'll be found here. And yeah, I can actually run Docker push now. That will push this image inside this repo that I will pull in the next job. So Docker push, and I will copy this image with version. I know it's not super correct flow. I need to release it via protected tags. Just don't have time for it. Now I need to not only push this image, but as we saw in Docker compose file, we need to provide this environment variable called service image in our case. So what I'll do is I will create a file called .env that stays for environment variables that will be automatically loaded in your system, not to type expert, this variable equals to this one. And this is one of the easiest and the recommended way to share environment variables between independent jobs in GitLab. So I will type a command echo, and we'll say the service image equals to, and what is equals to, again, this CI registry namespace colon version. And I will need to redirect it to file, but I am inside repository, inside folder rest fake name. I will need to go back one step back and create env file here. So it will be ..env. And I need to pass this env to the next job. For this, I'm using block artifacts. So this is how you can store the output of the job and either share between jobs or download in your local or share reports or whatever you want to have as the output of the job if it produces something. So there is a path, and just one path. I need only one file .env. Now it's not inside this folder, but inside root, so it's just .env. And then I think we're ready to write a test job. It's a tricky one, I know, but it might be a good example for future. So I can call it again any way I want. Run integration tests. And stage is, make sure we use existing stage. and image. Now I will need to work not only with Docker, but with Docker Compose. If I use the same image and install Docker Compose will not be here. It might be tricky to configure it. So I just Googled, find an image with Docker Compose, this one. And we'll copy this to here. And for tags, again, when you want to find tags, I just click on here. It's not recommended, by the way, to use latest tag, because if new one is published, it will be automatically used in your pipeline and you don't have a control of version. It's always nice to fix the latest but static version. If you want to switch, it's always nice to switch manually, making sure everything works, not to have surprises on Friday evening. Image is this one, and yeah, by the way, in documentation of this Docker Compose that is often used with GitLab CI, as you can see, use instructions for GitLab CI. It also says you can use services Docker DIND. I use specific version. Yeah, you can type your Docker Compose version, Docker info before, because it's all available. All these commands are available in Docker Compose. And yeah, you can type Docker Compose build up, whatever Docker Compose has. And it also has a very common question regarding uses this image, regarding this error. And they say, if you have this error, please reach out to this section where they provide this Docker TLS cert dir empty. So this is what we did already. Yeah, just find it across yeah, internet, collect everything, paste in one page. So script itself will be a really simple one. It will be docker-compose up, and I want this container not to be running forever because my tests will be finished by, but service will not be crashed or something. I don't want to run in detached mode. I really want to see logs. I want to see output, but I want to exceed it automatically. So I'll pass the flag -- abort on container exit. This will perform all the scripts, run test, finish test, and close this script, and we can move forward to block not before, after script. I want to save some output for developers, for myself, for sharing afterwards. So I will redirect Docker Compose logs to file. I will call it Docker compose.txt, let's say, or Docker Compose logs, yeah, to be more precise. Anyway, thanks. And in the end, I want to clean up everything. I don't want resources to be used. I will run Docker Compose down to make sure containers will be removed, all the volumes will be removed in the runner, and network will be removed as well. And that's pretty much it. A few configurations, like again artifacts, paths, and with path I will copy this txt file to show afterwards I can use it. And I need to make sure this job can use this env file, because I've stored this artifact in previous job, but I need to use artifact from previous job. For this, there's a special mechanism called needs. For needs, you provide a list of either projects or jobs. For this purposes job, you can copy job name and say artifacts true. That means this job will reuse artifacts from previous job. With this one, we will use env file. In env file, we use service image environment variable that will be passed automatically inside Docker Compose file here. Quite tricky, I know, try to follow. And the last one, I want to see report. This is what everybody asks, where we can see test result. Do you have something nice report? So as I configured my project with Surefire plugin. It saves reports under target. Target what? Target Surefire results. So first we will need to volume it in Docker Compose. So if I go back to Docker Compose, I add volumes and I say volume. I want to create some simple folder inside my Docker container. We'll call it reports, and we'll mount it to what was produced by the run. So I remember it was user app. Oops. User app. My bad. Then it will be target. Correct. Target, and then dash Surefire reports. This is where by default Maven will save this XML output of run. So now I have this in report folder. I go back to GitLab CI and add one more section under artifacts that calls actually reports. For reports, I need to provide a path to reports. I will say now JUnit because it should parse my JUnit reports. I have written tests in JUnit. GitLab supports quite a lot of tools, and the path is reports / test dash whatever .xml. Not only to grab only these files, not others that are produced as well. And I think that's it what we need. If I commit this.
Line 18.
18?
Yes, CI job doc. CI job doc.
CI, thank you very much. Never type it correctly from the first time. I will have some errors right now. So I will create a new branch called demo CI. We'll commit it. Sorry for being late. I didn't expect so slow internet connection. We'll try to finish quickly. So I'll expand this bar, and this is yeah, really nice with working of yeah, with this web ID. I just click commit, all the files are here, and CI/CD will be triggered automatically. So if you go to CI/CD and click on it, or go to CI/CD pipelines, yeah, I see I have invalid YAML file that you should always check. It says please check your file in CI lint. I'll go back, open web ID one more time. I'll get my CI YAML file, copy, paste. I cannot. Pipelines, CI lint, yes. Paste, click validate, and it will say job contains unknown keys, run integration tests. Jobs prepare service image. Let me see what is in this job. And it says contains unknown keys, run integration tests. Yeah, I'm not in correct level. It should be in the same level as this one. So I should fix indents. And yeah, let me commit it right here and see if pipeline is triggered. I go to CI/CD, still invalid YAML. Validate. Mapping values are not allowed in this contents on line 50. Indent, one more indent. Yeah, I've tried to use this web ID, was not successful. So it should be in the same level as job. Validate, yes. I don't need to create merge request for now. So with the creating correct YAML file, you should have pipeline trigger it automatically. with 2 jobs in 2 stages. You might have different jobs in 1 stage. We just have 1 job on build service. We have 1 job under a test stage. And while it's running, I will go back to microservice quickly. And I will use existing branch CI and we'll change it a little bit. So there is already GitLab CI YAML file. I'll explain what's happening inside. So I have built my project with Mivian package command. I run unit tests and I have deployed app to Heroku. It will not work for your case because you don't have configured these keys for Heroku app. You can easily do this and add these keys under settings, CI/CD, expand, variables, and add keys here, like create a key, copy this one, paste here, copy from Heroku, and you will have deployments from GitLab CI right here. And I added integration. It's a very new way actually developed last year by GitLab, how you can trigger pipeline from different pipeline. So I say in stage that I've created, integration tests in all the branches except master, because I want to only test non-master branches, run the pipeline from different project. So I need to fix it a little bit because I have a project in different namespace. It will be this one. So if I go to web IDE, do I have it here? Edit in pipeline editor. Where is this? I'll go back to branch, click web IDE, open this YAML file, and change. This is what you can actually do for your clone branches. Just change for your account. And branch, for my case, will be different that I have just created. It's called demo CI. In your case, it will be CI branch. It means this pipeline of development branch will build up, will run unit tests, and then will trigger different pipeline from different repo. This is very easy way how you can integrate your test automation into development pipeline. So it's still running. Prepare service image failed. I promise it will work in your pipelines. I think I made some typo. I will quickly show this. So I will click create commit. I will commit to this existing CI branch that will also trigger different pipeline for this microservice. And it will now have one more stage with the integration tests. It will take up to, I don't know, 5, 6, 7 minutes to build up, to test up, and automatically trigger the pipelines. In your case, you're triggering CI branch that exists, and you will see that test will be passed. Even counting the fact that there is a difference in implementation of this microservice in this branch. So I've changed first name and last name to full name and changed tests, and all this works before it's deployed to ACC environment. I'll not spend time to showing this. You can, now you have your projects forked in your GitLab, and you can change just this little paths to a correct repo. Stop wasting your lunch time.